All right, this is Moodify, visualizing the sounds that you've been listening to on Spotify. I'm Jeff,
I'm Alex.
And I'm Dan.
and Zpon is not here with us, but she will have a part later on. We'll add the recording. This will be our demo.
All right, this is Moodify. Visualize your listening history with artificial intelligence. So here I'm going to use my information to log in, and also we're not saving any emails or passwords. Here we are generating visuals. This is where we're calling the OpenAI API and getting that image. So here's my recent songs, visualize, as well as my past moods. So over the past few weeks, this is what I've been feeling. All right. We can also download the image and then share it to our friends or family. So we have Twitter, Reddit, and Pinterest due to restrictions of the React library I used, but it gets the job done and we hope to implement more. All right, then let's head on to the community page where we can check out other users' past moods. This is fetched from the database. Here we have the about. Then we're going back to home to show off what React Query can do by saving the generated image so then we don't have to repetitively contact the OpenAI API. Then we have this Send Love page, which is a placeholder for donations for future live launches so we can support the Google Cloud Platform's bills and also the OpenAI billing system.
All right, after our demo, go over the system design overview. Everything is hosted on the Google Cloud platform. Starting from the front end, it's hosted on the Google App Engine and it's run on JavaScript. And we're using JavaScript libraries such as React, React Query, and Axios to fetch APIs from our backend. And the front end will interact with Flask. But then I'll pass it on to Dan to explain the backend.
Yeah, so basically the backend we're using, as Jeff mentioned, Flask. Pretty straightforward. We've been looking at that in class. But for the database, nothing has really changed much in terms of the tools that we're using to store our user information, as well as the images that we're creating. Yeah, we're still using Google Cloud storage with the buckets to hold the actual image files, and Google Cloud Data Store to handle the relevant sort of user information. There's a few things have changed though. For the user information, we're storing username. We're also storing the path to the image file, and we're just using the public URL provided by Google Cloud Storage to access those images. So it's very straightforward to just put the image name in the Google Cloud Data Store entity, and then whenever we do a query, we can just sort of append that name to the end of like the URL for Google Cloud Storage. So it works really well. I implemented a change to let users create multiple images just by I used to have the ID be for the entity be the what's it called, the username, but I changed that to something different so that way users would be able to create more than one image and that for that image to persist.
Sweet. And then going on to the client server side of things, I'm going to give an example of communication going from the React front end to the Flask backend. So this is for image generation. As soon as the user clicks login with Spotify, it sends an authentication request to Flask, and Flask hits up the Spotify API, and the Spotify API will send a website URL from hosted on their end and doing all the authentication stuff. So then all user data is not held, or any personal user data, such as password, is not held by us. And once authentication is successful, it'll redirect us to Moodify. And Moodify will give us this key that will let us access the user's songs, or generally the user's listening history and user ID. And after that, we request an image, and that image will go through several OpenAI calls that first generates a prompt and then to an image. And that image URL will then be sent to Moodify. And also, disclaimer, all user identification is handled by Spotify's OAuth, and we do not store anything except usernames and images, as said before. I'll pass it on to Alex.
So for the prompt engineering, this was an area where there was a lot of like struggle and concern of like, how is this even achievable? Like from a basic standpoint, it's something that we did have success with, but then the revamp of the prompt was our biggest problem. For example, how do we make it unique? How do we generate these like descriptive prompts to actually get a good image? What happens if there's repeats? And it wasn't until like the hype of Chat GPT that everyone's been talking about, where Jeff actually made a realization that we could just use this um, AI chatbot to like generate the prompt for us, and we don't have to overcomplicate it. And so, like for example, training and designing our own model to the level where like the OpenAI chat completion is something like that is really hard to reach in like semester like this. Maybe in 1699 it'll be revisited. Um, but yeah, so we just use their API's text completion to generate us a prompt from like whatever input we give it. And so we simply just take like the user songs and ask the model to generate a prompt inspired by the song titles. And so this is kind of like how the flow works. We use a Spotify API, and that returns us a list of songs with the artist. We format these into our prompt template, and then this is pushed into the OpenAI API, where it returns us back a generated prompt with descriptive details about the song. And then finally, that prompt is fed into the image generator. And here's just an example of one that I've been testing. So we just tell, like, for example, make a creative prompt that describes the mood over the songs. And so here, like a list of 5 songs, for example, my most popular ones. And it returns back this very descriptive image. You could see like certain songs where it takes inspiration from. Like we have Space Song, and all the images have like a space theme to it. One of the songs is named Water, and there's water present everywhere. This night has opened my eyes. There's a night sky. So you can see that this prompt is taking inspiration from it and just making these like images that it'd be very hard to create a unique prompt each time for a user without something like this.
Hi, let's talk about the Stable Diffusion. Stable Diffusion is a Latin textual imagery diffusion model capable of generating photorealistic imagery given any text input, cultivates utmost freedoms to produce incredible imagery, empowers billions of people to create stunning art within seconds. Yeah, and this is the Stable Diffusion model. And here's the image modification with Stable Diffusion, as you can see this picture right here. And then let's talk about which API we use that. We use the E2 API, which is from the OpenAI API one. Yes, and also the E2 API actually is inspired from the Stable Diffusion model. So yeah, and so why we choose this API? Because it is a new AI system that can create realistic image and art from description in natural language. And yeah, basically it can create the realistic image that, and also like art from a text description, and it can combine their conception, attribute, and styles. And second one is they can make realistic edits to extend images from a natural language caption. And third one, the third reason is because it can take an image and create different variable, like variations of it explained by the original one. Well, also the Dell E2 has learned the relationship between the image and the text user described them. It's user diffusion model. So as I mentioned that before, why we want to use API just because it's really easy to use that, and it's have the high quality images as, and also the GPU enable and the faster generation. So this basically why we use that. For example, when you just type in close-up studio photographic, sorry, it's photographic. portraits of a white Siamese cat that looks closely regulate ears, which, as you can see, that the right side picture is what this text come out of the imagine that. And why here is a price for OpenAI API. Would we use this API? And another one is language model. Yeah, so basically, yeah, and this is price for that one. So yeah, you can see this is we spent for that.
All right, the end. Thank you.